Welcome to the fourth video in the We Are Ready series to prep students at Speedway High School for the ISTEP 10. This is aimed at retesters. So again, we're focused on part 2 of the ISTEP, the multiple choice short answer, graphing, drag and drop, those questions. Okay, those are the questions we're focused on. We put a lot of emphasis in school on the open-ended already. So here we have 3 points. We're asked a number of things about that. We're asked the independent variables, the dependent variables, and to determine an equation. So first of all, everybody in my class had better know that the independent variable is x, meaning that's asking for the x values, 2, 3, and 7. So we would say, oh, the independent variables, well, that's the domain, 2, 3, and 7. And we should list those. Now, you may not need the curly brackets, but you probably would just say 2, 3, 7. Or it might be a multiple choice question. Either way, you should know that the domain is made up of the x values, which is the independent variable, and is the input of the relationship. Okay, you should have those 4 words burned into your brain as being associated with each other. Then it says what numbers represent the dependent variables. Well, that should instantly trigger that that's the y values, 7, 10, and 22, the range. No, it doesn't matter if you list them in order. I know that at least one of your teachers told you it did, but it doesn't. The range should instantly be connected in your head to the y values, which are the dependent variable and are the output of your relationship. There are several lists of words throughout the year that I have said all at the same time every time, so that you should, in your head, relate them to each other. Okay? You should relate those sets of words to each other. If not, just repeat them to yourself until you do. All right. Determine the equation for the relationship between the independent and dependent variables. Ladies and gentlemen, if they give you multiple points and they ask you to determine the relationship between those points, chances are real darn good that it's a linear equation. Real darn good. Okay? But in this case, they're really not. I hate to put it that way, but they're not. If we look at the relationship, the change in x between the first 2 points is 1. The change in y is 3. That makes the slope 3 over 1. But if we look at the relationship between the next 2 points, 3 and 7, that's a change of 4. 10 and 22, oh no, they are linear, never mind. Ah, I'm an idiot. Okay. So they are linear. So we need to find a slope. Okay, that's our first step, is to use the slope formula, which is on the reference sheet. Okay, it's on the reference sheet. So we go to the reference sheet and we find slope right there. y2 minus y1 over x2 minus x1. Okay, now when it says y2, y1, x2, x1, it's referring to 2 points. So we have, for instance, x1, y1, x2, y2, and if we wanted to, we could call this x3 and y3, because the subscript's just marking what point it's from. So the slope would be y2 minus y1 would be 10 minus 7. x2 minus x1 would be 3 minus 2. That's 3 over 1, or a slope of 3. Now, normally you'd want an intercept. We don't have an intercept, but we do have a point. So we should go back to our reference sheet, and we should find the point-slope form of a linear equation, which is located right here. Point-slope form, y minus y1 equals m times x minus x1. So we could plug it right into that. So let's see here. That would be y minus y1 is 7 equals m, which is 3, see, look right here, 3, times x minus x1, which is 2. Technically speaking, that's the equation right there. You could put that on that line and you would get full credit. But if you're more comfortable with slope-intercept form, then you would distribute and then add 7 to each side, and you could get 3x plus 1. So you'd either say y minus 7 equals 3 times x minus 2, or y is 3x plus 1. You could give either one of these answers and you would receive full credit for that problem on the ISTEP. They don't care what equation you give as long as the equation is correct. So it doesn't matter if you give them the point slope form or the slope-intercept form. Either one would be accepted. Heck, you could give it to them in standard form, but that'd be kind of dumb. Okay, next up we have factor the given problem, and we have a trinomial, x squared minus 11x minus 26. Now notice that this is a trinomial where a is 1, which means we can factor that straight away into two binomials, the first term of which is x for both. Now when we go to look at our pairs of numbers, instead of doing a times c, a is 1. So we're looking for numbers that multiply to c and add to b. So we're looking for two numbers that multiply to negative 26. So here are your options. And add to negative 11. Well, that adds to 25, that adds to negative 25, that adds to 11, and that adds to negative 11. There's the one we want. So the numbers that we plug in are positive 2 and negative 13. And that's the factors. The two factors are x plus 2 and x minus 13. I hope you're good at factoring, because factoring is something we've spent quite a bit of time on in algebra. On to number 3. Jonah is going to the store to buy candles. Small candles cost $3.50. Large candles cost $5. He needs to buy at least 20 candles, and he cannot spend more than $80. Write a system of linear inequalities to represent this situation. So inequalities means we're not using equal signs, we're using greater than, less than, or greater than equal to, less than equal to. So we need to define our variables. Let's say we let x represent, and this is actually a good talking point, the number of small candles, and let y represent the number of large candles. On the first section of the ISTEP, you are almost guaranteed to have a systems word problem. And the first part is going to say, be sure to define your variables. If you say, let x represent small candles, let y represent large candles, you are going to lose a point. Because you are either representing the number of those items or the cost of those items. So you need to be precise in your language. In this case, we're going to represent the numbers. So we have two equations we can write. We have a quantity equation, or inequality, which is based on must buy at least 20 candles, that section of the word problem. And we have a cost or value inequality, which deals with the prices and spend no more than $80. Okay? So that's two different sections of the word problem. Okay? We have the prices of each type of candle. We have that the small candles are $3.50 and the large candles are $5. That's what I mean when I say the prices. Okay? So, your quantity inequality, it says he needs to buy at least 20 candles. Well, if X is the number of small candles and Y is the number of large candles that he purchases, and he has to buy at least, well, we need to know that at least is greater than or equal to. That's what that set of words means. So X plus Y is greater than or equal to 20 candles. That's the first inequality. Okay? Then we have the phrase cannot spend more than. That has to be less than or equal to for a symbol. So here we have to attach the cost of each candle type. So we have $3.50 times X plus $5 times Y is no more than $80. Now I'm not going to put 80.00, and really you don't need the 0 here or the 2 zeros there, but I find that writing them this way helps with dollars and cents. This would be the correct system of inequalities to represent this situation. Okay, this last question is not a great question. It's not worded well. Technically speaking, on the ISTEP, it would not show you equals 0. It would say, what would you do to find the zeros of f of x? Okay? Well, again, zeros is a word that you should immediately represent with several other words. You should immediately realize that zeros is the same as solutions, is the same as roots, is the same as x-intercepts. Now, if it says zeros, that's meaning we're supposed to solve. So that's why this particular worksheet says equals 0, because that's what you're supposed to do. You're supposed to plug in equals 0 and solve for x. Okay? Now, that is a factorable trinomial. So again, when we factor a trinomial where a is not equal to 1, we do a times c, which is 6 times -2, that'd be -12. And we look for a pair of numbers that multiplies to a times c and adds to b. Well, b is 1, positive 1. So when we look at numbers that multiply to 12, there are only so many options, 6 total. We're looking for the pair that adds to positive 1. That would be this set. Now, we did one of these in an earlier video. These are not the numbers that go into the brackets. We have to break that trinomial up and factor it by grouping. So 6x squared, and then we have plus 3x minus 4x minus 2. And that still equals 0. I apologize for this getting so close, by the way. Then we group. So we group the first two terms and the second two terms together. Now in this case the negative has to go with the 4, so we would insert a plus sign in there temporarily so that we don't think we're supposed to multiply. Then we factor out the greatest common factor. The greatest common factor of these two is 3x, which I would then factor out, and I'd be left with 2x plus 1. Here, the greatest common factor would be a -2, which would leave, not coincidentally, 2x plus 1. And that still equals 0. Now look at what we've got left. They have a common factor, which is this binomial, so we'd factor that out next, 2x plus 1. And that would leave what's left in front, 3x minus 2, to be in the other set of parentheses. So if you look, this is what they're looking for, an equivalent form of the same equation, just with that trinomial factored. So if we look up here, we don't have a 2x minus 1 in our answer, so A is eliminated. So is C, because it has a 2x minus 1. So is D. That kind of narrows down that the answer must be B. Now, if you're not great at factoring, here's a trick you could use. You could FOIL these answers out to see which one is equal to 6x squared plus x minus 2, and that would work as well. Okay, guys, again, I really hope this is helping. I'm putting in the effort here. I hope that you're putting in the effort on your end, because I know you have the math skills to pass this test. You have to believe it. Doesn't do any good for me to believe it. You have to believe it. So let's defeat that ISTEP. See you in the next video.